present our work efficient SPARQL to SQL translation with user-defined mapping. What is the motivation to do this? Although our RDF format is great for publishing data, it is fact that the mostly used way how to store data is the relational database system. For curiosity, I've included some comparison of the database engines and their ranking, and as you can see, the first and the top rated store which supports RDF is MarkLogic, and the score in comparison with Oracle, for example, is, let's say, funny. So, how to close this gap between a relational Word and RDF format? We can definitely duplicate the data. That means we can dump a relational database in RDF format. There are standards to do this. You can find them on the V3C consortium. Direct mapping and R2RML mapping languages, and there are many tools using these languages to create the dump. However, if you go this way, you will have always outdated data, and you will need to manage the data into a data store instead of a single one. The second option is to use the virtual endpoint. You will not create a dump, you will just virtualize the endpoint, and for every SPARQL query you get, you will translate it to SQL query, query the relational database, get the results, and transform the result back to the form as if it is executed against the RDF store. So we are not the first one doing this. There are several approaches. One of the first one was D2R. The initial versions was from year 2004. It is still mentioned as state-of-the-art tool. It was before even the standards for mapping was introduced. They used their own language and they were able to operate. If you have enough time and memory, that means that for larger datasets you are not able to do anything. After that, they started to think how to query the relational database using a single query. There were a research group around Chaloupka which introduced a method how to query a relational database if you have a single table with 3 columns: subject, predicate, and object. Using that, there was created an ultra-web tool which separates the, which separates the query into 2 parts. The second one is the one which was developed by Chaloupka. That means query as if it is in a table with subject, predicate, and object, and the view, which is before the query, which provides using all the mapping, provides the relational database in the form as if it is a single table with 3 columns. This outperforms D2R. It works quite well because the relational database engines are optimized. So it is not as bad, but still for more complicated queries for huge datasets, it doesn't perform very well. So another step is to remove this part and make it as a single query and reduce the amount of joins which are causing the lack of performance. That was done in the tool called OnTop. Again, it outperforms UltraWrap. It is done in a simple way that it translates SPARQL query into SQL query in quite a direct way, and then uses known ways how to optimize a relational query. It uses candidate selection and self-join optimization, and the created query is quite good. And although there is probably something to improve, there is not so much to do in comparison to the other part of the query creation. So what we do is we are focusing on the part when we are creating the query and processing the query results. The middle part, that means the query effectiveness, is quite equal in comparison to on top. So how our tool works? First part is that we parse the query in the SPARQL algebraic form. I will show the individual steps using simple query, querying list of students with their names. As you can see, there is one triple array RDF type X students, array X name, and it is joined. Next step is to include the mapping to database. That is difference between on top and us, because we have enhanced the SPARQL algebra to include the mapping information. So we start with the join, as you saw in the UltraWrap solution. Every triple pattern was replaced by union of all triple patterns restricted by some concrete mapping. And now we can do optimizations based on the mapping information we have, because for every mapping we can decide whether it is possible that it will return results or not. And it will simplify, it usually simplifies the algebraic tree, that in this case we get only 3 triple patterns left, but there is still union. What we can do about that? Simple operation, we get the union to the top, and now we have 2 joins unioned. Again, we can use another candidate selection, because we now can decide whether these joins can return results or not. They have a shared variable, array, and for example in R2RML mapping you can use template to create arrays, and we can decide whether 2 different templates can match or not. It is quite common that this method will remove all unnecessary queries to the database. So after that we will get only one side. In that scenario we remove the right side, because we decided it can't return any result. So now it is simplified. It looks the same way as it was in the beginning, but now we have the mapping information here, and the mapping information adds us the concrete information how the query will look like. After that we can start translating into the query. Left part, array RDF type students, we are asking just for ID from the table students. In the second case we are asking for ID and array and name, and we are asking for ID name for table students. Here are some conditions defined by mapping that is according to the R2RML definition. When we join them together, we have a join condition on them, which is in the form that either one of the array is not bound or their values are equal. After that we can continue on optimization on the SQL query. That means first step is remove this weird condition, because this condition is for sure equal if the IDs are equal. Next step is that we can look on the database schema. For example, we can see that ID and name are not nullable columns, so the conditions doesn't make sense, and the query is simplified. After that, last step is needed. If the ID is, for example, primary key, we can detect that this is actually self-join, and we can simplify the query further. After that, the final step, converting this clause to the actual SQL query, and connected with that we need to have the information how the actual SPARQL variable is represented by the query. Now it goes back. As I've said, we had variable array, but there is nothing like array in the returned results. So we are processing the query results and creating the variable values according to the rules we created before. There is some small evaluation of our tool in comparison to OnTop. OnTop is currently taken as the best performing tool for this task. We are outperforming it. I have not found any query where the OnTop will outperform us. It doesn't seem to be so big, but there is logarithmic scale, and for example, in the first query we are 3 times faster, and in the last one we are like 20% faster. The differences between the performance is that we create the query faster and that we process the results much faster, because the row processing and the condition how to create the SPARQL result variables are much simpler. So, thank you for your attention. If you have any questions, there is place right now, or you can catch me at any time.
Thank you. Yes?
New evaluation chart at the end, you would like compare with the execution time. But did you compare with like the translation quality between like, is it correct translation or not?
Both cases were correct translation, as I have said in the beginning. In comparison with OnTop, the queries are quite similar. They are just minor tweaks, like how the SPARQL variable is represented in the query. But the most important part is as we have found, is the count of joins in the query. Whether you have something unnecessary in the query, that was the candidate selection, because you can end up in a union of several queries and actually only one of them will return something. And one more thing quite important was avoid these conditions. They are pretty slow. And in these terms, we are equal. There are some minor tweaks, but these huge problems, they are not in our query and even in their query.
But in all cases, the results are the same. I mean, the query results are equal for all the forms of queries. It's just a matter of optimizing the query.
Yeah. They have to be same, otherwise the tool will be invalid.
Okay, thanks. Question?
Just one question. How you select, for this particular slide, how you select the queries on which you tested? Is there some golden set of queries that is usually used for performance testing?
This evaluation was used as a selection of 5 queries which were used for some typical scenario which will be used by applications. It was used on drug database in Czech Republic, and there was scenario like the first one is I want to get list of drugs with some specific addiction, then I list detail of it, and as I go in the end, there was some like 50,000 drugs with some specific containment. So it was chosen as a scenario of selected queries, one after another.
Okay, thanks. Next question.
I can ask the relational database which you are working for. Is it just any database, or did you change the structure anyhow? Do you store the triples just inside the database, or?
It's designed in a way that you will have the data stored as you usually have. Then you have a mapping file. It's in R2RML format. You can find this standard, and you describe how the relational data is represented in RDF. This format was created to create a dump, and we use the same format to translate the SPARQL queries to SQL queries. So you are not modifying the database anyhow, you just define the mapping and it works.
Any more questions? Okay, I have one more question, and it deals with, can you imagine a query that would outperform worse in you than in OnTop?
Well, I can imagine one query which is very bad for my tool. I don't know how OnTop behaves in that way. And it is not so related with the query, it is more related with the mapping. For example, if you have a single entity represented in multiple tables, let's say that if you have nuts entities and you will have 5 tables for regions, countries, etc., then the mapping will target 5 tables, 5 different queries. And in the optimization, when we are doing the selection, we will not be able to remove them because we will have no chance to decide whether it is country, whether it is region, etc. And in that case, I'm currently creating a huge query because I currently have no mechanism to detect that it is not good to optimize it right now. So that is one of the future works for me to detect the dead ends of the query optimizations.
Okay, thanks a lot. Okay, and the last talk in this session will be given by Masaharu Hirota. Live or stay, classifying Twitter users into residents and visitors.